Students, we are given this question: solve y positive root of x squared positive y squared times dx negative x times dy is equal to 0, given when x is equal to 1, y takes the value 0. Now, first I want to show you that it is a homogeneous differential equation. So what I need to do is I need to move this x dy, because it's negative, to the right side. So you would have y positive root of x squared positive y squared times dx is equal to x times dy. Now this is same as writing x times dy is equal to y positive root of x squared positive y squared times dx. Now I bring the dx down, so this is dy over dx is equal to y positive root of x squared positive y squared divided by x. So this is what we get. The degree of y is 1. Now the degree of x squared positive y squared, since they are under the square root sign, definitely their degrees are also equal to 1. The degree of x is 1. So clearly the numerator's degree and the denominator's degree, they agree. So this means this is a homogeneous differential equation. Okay. So since this is a homogeneous differential equation, I would be making the substitution that let y be equal to vx, and differentiating with respect to x, we get, so this is going to be dy over dx is equal to v times differential of x positive x times differential of v, which is dv over dx. So I would be using, in place of dy over dx, v positive x times dv over dx. So if I were to take this as 1, therefore 1 now becomes v positive x times dv over dx is equal to, in place of y you substitute vx positive root of x squared positive v squared x squared divided by x. So we got v positive x times dv over dx is equal to, I'm going to take x out, so that would give me v positive root of x squared positive v squared x squared. So from the square root I can take x squared out, so that would be 1 positive v squared with a square root there, positive vx divided by x. Now this can be rewritten as x with vx there, positive, x can come out of the square root, so that would mean I have a x there, times root of 1 positive v squared divided by x. Now the x that you see in the denominator can be cancelled with the ones in the numerator, so that would give me v positive root of 1 positive v squared. On the left I've got v positive x times dv over dx. Now moving the v to the right gives me x times dv over dx is equal to v positive root of 1 positive v squared negative v. The plus v and the minus v can be cancelled, giving me x times dv over dx is equal to root of 1 positive v squared. Now using variable separable technique, I can rewrite this as dv divided by 1 positive v squared with the square root, moving dx and bringing the x down, I would have something like this. Now integrating both sides, we get, so this is going to be integrated. Now using the formula integral of dv over root of 1 positive v squared, I can clearly write this as ln of v positive root of v squared positive 1, or 1 positive v squared, is equal to ln of x positive ln of c. Okay. Now this can be further rewritten as ln of v positive root of v squared positive 1 ln a plus ln b. That's going to be ln x and c. So this is what we get. Now we know that y is equal to vx, so therefore v is equal to y over x. We know that. So I would have to substitute that. So what I'm going to do, I'm going to be using this space here. Okay, so we have got ln of modulus of v positive root of, let me write it as 1 positive v squared, is equal to ln of xc. This is what we have got. Now removing log both sides, okay, removing ln both sides. So when you remove ln both sides, you would be getting modulus of v positive root of 1 positive v squared is equal to x times c. This is what you get. Now since I've told you that y is equal to vx and v is equal to y over x, if we substitute that, we would get y over x positive root of 1 positive y squared divided by x squared, okay, is equal to x times c. Now I can rewrite this as y over x positive, taking the LCM, this is going to be root of x squared positive y squared divided by root of x squared is equal to x times c. This is rewritten as y over x positive root of x squared positive y squared. Square root of x squared will give you x. You can place the modulus sign, is equal to x times c. Taking the LCM, you get y positive root of x squared positive y squared divided by x is equal to x times c. Moving x to the right side would give you y positive root of x squared positive y squared is equal to x squared times c. So this is a beautiful result which you have got. Now the solution is not complete. We need to find the value of c. So I'm going to use this space here. Okay. So when x is equal to 1, y is given to be 0. So y is 0, x is 1, y is 0. So clearly you will have something like this: 0 positive root of 1 positive 0 is equal to 1 squared times c, which implies the value of c is equal to 1. So if I were to use this value of c into the solution here, then the solution will be rewritten as y positive root of x squared positive y squared is equal to x squared. So this is going to be the final answer to the question.